Guys, Mr. Gibson here. I'm going to show you guys a microeconomics FRQ. Um, and this one actually includes everything that you could possibly see on, not everything you could possibly see, but it only includes stuff that uh, would be on the test this year. Okay, there's nothing about externalities on this one, so it's a pretty good indication. Also, you don't have to do graphs, and this one has a pretty good example of where yeah, maybe you won't have to draw a graph, but it's going to be important for you to understand the graphs and to draw them so that you can answer some of these questions. Okay, so let's jump right in here. We have Gigantic Pharmaceutical Corporation has a patent on a prescription drug, making the only manufacturer of the prescription drug. Gigantic is currently earning positive economic profit. So they want us to draw the graph for this firm. And guys, most years, this is the first question on the test is to draw some sort of firm. Excuse me. In this case, we've got a monopoly on this prescription drug. So we'll draw a monopolist graph. We're gonna have to draw the ATC, making sure that we can show that there's positive economic profit. And we're going to also show some consumer surplus. So that'll be a little different this time too. So let's get right on into it. I always like to put a little dollar sign on the horizontal axis because it represents price or cost. And then, of course, the quantity for the monopolist. The monopolist is the market for the product, so it's a downward sloping demand. And there is a marginal revenue that is downward sloping as well. And we'll have this little check mark looking marginal cost curve where marginal revenue equals marginal cost. That is the profit maximizing point, Q sub G in this case. So that determines the quantity that the firm is going to produce. At this quantity, consumers will demand the product at this price. Okay. All right. So now we've got to draw an ATC that represents positive profit. ATC will minimize at the marginal cost. So we're going to make sure that we have the minimum point at the marginal cost curve. But we're also going to make sure that we draw it so that the ATC is somewhere between the price and the quantity right here, somewhere in this region right in here. So just to make sure that we're showing positive economic profit. Again, I don't have to draw this, but I'm going to draw it anyway. ATC would be right here, which means the price is greater to ATC. That means that we have positive economic profit. Okay. So I drew the ATC there so that we have positive profit. Okay. I couldn't have drawn it up here because that would have been negative profit. So as long as it's anywhere below the price, we're fine. Okay. Or where the quantity would intersect below the price. Okay. Anyway, next thing is shading this region of consumer surplus. So consumer surplus is underneath the demand curve, but above the price. So this is all represents all the folks that got to purchase this at a price that was below their willingness to pay. So there is some consumer surplus here. Okay. All right, so there's number one, just setting ourselves up. Okay, suppose the demand for prescription drugs increases and Gigantic hires its warehouse workers in a perfectly competitive labor market. What will happen to Gigantic's demand for warehouse workers? Explain what will happen to the wage rate Gigantic pays its warehouse workers and the number of warehouse workers it hires. So again, this is a great example of something where they don't ask us for a graph, but a graph is going to sure be helpful, especially if we understand the graph. So if we remember, you have labor and we have a wage rate, okay? And we have a demand for labor, okay? That is what we call derived demand, okay? It is the marginal revenue product of a demand curve or of our product. So it's the marginal revenue times the marginal product of labor. Okay, that's what we mean derived demand. It's derived from the actual market itself. Okay, and of course this would be marginal revenue product because we're a monopoly. Okay, the marginal, it wouldn't be value marginal product because the price is changing, the revenue is changing along our demand curve for our monopolist. But that's his demand. That's a perfectly competitive um, labor market. So that means that we're wage takers. Okay. So we have a horizontal supply curve of labor that's right here at the market wage rate. Okay. So this is for our firm. All right. Now, if the says the demand for prescription drugs increases, so if the demand increases, that also means the marginal revenue is derived from the demand curve, so that also means that marginal revenue is going to increase as well. Okay, so that means that our demand, because it's based on marginal revenue, is also going to increase. So if we look here, Gigantic is going to hire more laborers, but they still have to take that same wage rate. Okay, so let's go ahead and answer these questions. Um, their demand increases, and the reason why it increases, there's our explanation. The marginal revenue will increase per worker, so that with the demand for uh, warehouse workers will increase. Okay, what will happen to the wage rate? It'll stay the same because we're wage takers. We're in a perfectly competitive market, and the number of warehouse workers it hires will increase. And we saw that graphically. Okay, so number two, you didn't have to have an explanation, and number one's explanation is that we have this derived demand, and as demand increases for our product, that means marginal revenue will increase, which will increase the demand for warehouse workers. Okay. Alrighty. All right. After Gigantic's patent expires, another firm enters the prescription drug market and produces an identical drug that sells at a lower price. What will happen to Gigantic's producer surplus? What will happen to the consumer surplus in the prescription drug market? Explain, okay? We can explain both of these just kind of intuitively, and I'll do that first, okay? Well, producer surplus for Gigantic is going to go down, okay, because uh, the price will decrease and the amount that Gigantic is actually producing will decrease. So that's bad for the producer. Okay, so you don't even have to explain that. Consumer surplus, well, that'll increase because simply the price will increase. It will decrease, and if the price decreases, the consumer surplus will increase. So we can see it graphically because again, it always is helpful to see stuff graphically. Um, a lot might happen to this demand curve, okay? Because so you can't really assume, but what you could um, possibly show is, I mean, we can see where if the price decreases right here. So right now, speaking of, this would be producer surplus before all this, and let's say the price decreases right here. Okay. Look, there's more consumer surplus right there, but our producer surplus looks like it goes down a little bit. Okay. All right. So we can explain that intuitively. Let's look at some of these answers. Oh, well, let me see real quick. Is that it with number? Oh, yep, it is. Okay. Just three parts of that one. That's a little unusual. Scoring guidelines, real quick. There's our demand and our marginal revenue, marginal cost. There's our profit maximizing Q sub G. ATC curve, make sure I'm drawing that so that at that quantity, our ATC will be lower than the price. Could have drawn that infinitely many ways, but make sure that it's right there. P sub G, of course, is where the demand, uh, where folks, where people's willingness to pay is, and then of course consumer surplus is between the demand curve and the price. Gigantic demand for warehouse workers will increase, and that marginal revenue product of labor increase because of the increase in the product price. Okay. So you probably wanted to mention something about prices. That might be one slight problem with my explanation. 1 point is earned for saying that the wage rate will not change and the number of workers will increase. We saw that graphically. Um, because a producer surplus will decrease. Okay, we talked about that intuitively, and saying that the consumer surplus will increase, and for explaining that because of the increased competition, the price will decrease and the quantity will increase. Yes, so we saw that graphically, and we'd have to explain that. Okay, all right, perfect. Let's move on to number 2. Okay, hats are produced in a perfectly competitive industry, and the government imposes a per unit sales tax or an excise tax on hats. Using the labeling from the graph, identify each of the following. I might just do it on this page. If I have to use the other page, I will. But let's just kind of look. Using the labeling from the graph, identify each of the following: the after-tax price paid by consumers and the after-tax quantity. Okay, so all right, so that's so this is the equilibrium with the tax. Okay. Consumers are going to have to purchase this at P sub 3. And if you go down here, this is Q sub 2. All right. Area representing tax revenue received. So uh, this is the price paid by consumers. You come down here to the supply curve, and this is the price that the producers get. This Q sub 2 is the quantity. So this area right here is the tax revenue. Okay. It says so the area would be P1, P3, um, SZ. Okay, that rectangle right there. Okay. Now, assume instead the demand for hats is perfectly inelastic. Okay. Erase this real quick. Um, at Q3, so I can kind of draw a new demand curve right here. So demand's perfectly inelastic at Q3. Okay, like that. While the supply and the per unit tax remain unchanged. Okay, perfect. Okay. Will the after tax price paid by consumers be higher, lower, or the same compared to the price in 1A? It's going to be higher. Okay. You guys can see this because it's going to be right here versus right here. Okay. So that's one way to see it because that went from P3 to P4. Okay. The other way is a more explanatory way about when we explored in class, the more inelastic the side is, either demand or supply, then the more of the tax burden. And if it's perfectly inelastic, um, the tax burden is going to be entirely on the consumers. And you can see that too, because now for the producers, they get to produce at this same price that they would have um, if the supply was just where it was at. Okay. The problem now is look, the consumers have to consume at this price P sub 4. So nothing really changes for the producers. A lot changes for the consumers. Okay. Will the total tax revenue received by the government be higher, lower, or the same compared to the tax revenue in part uh, 3A? So it was P3 times this Q2. So the quantity has gone up that they're producing. And this gap between P4 and P2 is bigger than P2 and P3 or P3 and P1. So uh, the tax, the government's going to collect more taxes. Okay. They're going to collect way more taxes. Okay. The demand for hats remains perfectly inelastic in Q3, and the per unit sales tax is reduced. Will producer surplus increase, decrease, or stay the same? Explain. And it's going to stay the same, okay, because the tax burden is all on the consumer, okay. And also, you can kind of see, look, if we just move the supply plus tax to right there, Well, that doesn't affect how the price that the producer's producing at, nor does it affect the quantity. Okay. So it doesn't affect the, so you can see it graphically. You can explain it that way, where it doesn't affect the producer at all. Or you can make that explanation of like, look, if it's perfectly inelastic demand, then all the tax burden is on the consumer. Okay. So let's look at some of these answers to this. P sub 3, Q sub 2. I said P1, P3, S, and Z. Okay. Or you could kind of do these little calculations here to show that. But the P1, P3, SZ, that works as well. Um, the other 1 point is earned for saying that the price paid by consumers will be higher. 1 point is earned for saying that the tax revenue received by the government will be higher because tax does not reduce the quantity purchased when the demand is perfectly inelastic, while the quantity does fall when demand is downward sloping. So that's a little more intuitive, right? So that's the problem with the tax. Usually, is there is some sort of downward sloping demand. So if you tax something, the quantity will reduce. But in this case, if it's perfectly inelastic, the quantity doesn't change at all. So they receive more, okay, than if it wasn't inelastic. 1 point is earned for saying the producer surplus will stay the same. For explaining that is both because the price received by the sellers and the quantity sold does not change. Okay, again, that's seeing it graphically, or also acceptable to explain that the producer surplus stays the same because the consumer bears the full burden of the tax. And of course, that's because it's a perfectly inelastic demand. Okay, so whoever's more inelastic bears more of the burden. And if somebody is either perfectly inelastic or supply or demand, they're going to take the total burden. Okay, finally, we got us um, a game theory question. Okay, with a payoff matrix. Okay, so we got Jackpot Florists and Boulevard Gardens share the market for floral boutiques in Tulip Town. Jackpot is deciding whether to close at 6 p.m. or close at 9 p.m. And Boulevard is deciding whether to offer delivery or no delivery. The payoff matrix above shows the annual profits for each combination of actions that the firms can choose. The first entry shows Jackpot's profit, and the second shows Boulevard's profit. Okay. Assume both firms know all the information in the matrix and act simultaneously and independently. Okay, so they're independent, but they're interdependent. Okay, they act independently, but they're interdependent. Their decision affects each other. Okay, is Jackpot's dominant strategy to close at 6 p.m. or to close at 9 p.m., or does it not have a dominant strategy? Okay, so how we're going to do this is we're going to pretend like we're Jackpot. And first, let's think about what we should do if Boulevard offers delivery. And if they offer delivery, it looks like 35 is better than 25. So we will close at 6 p.m. Okay. So if there is delivery, close at 6 p.m. No delivery, well, 55 is greater than 45. So again, Jackpot will close at 6 p.m. So they do have a dominant strategy to close at 6 p.m. Oops, sorry. Okay, B. Suppose Jackpot chooses to close at 6 p.m. and Boulevard chooses no delivery. Okay, so Jackpot is here at 6 p.m. and they've chosen no delivery. So I'm just going to circle this. This is our payoff right here. Okay. Is this profit maximizing action by Boulevard? Explain it using values from the payoff matrix. And I would say no. Okay, it's not. It is not because uh, if they chose to deliver, they would get $30 rather than $20. Okay, sometimes these payoff matrix questions are a lot simpler than you think. You just have to look at it and be able to interpret. Okay, how much profit will Boulevard earn in the Nash equilibrium? So the Nash equilibrium is where there is the place on this payoff matrix where there is no incentive for either side to cheat, and that place will probably be right here. Okay, and that's because Jackpot has a dominant strategy to. Uh, we've already shown that Jackpot has a dominant strategy to close at 6, and if they're going to close at 6, because that's their dominant. We see that Boulevard will choose to deliver. Okay. So that's where we're going to be. And you can see that there's no reason to cheat because um, if they decide to cheat, Boulevards decide to cheat, they would lose $10 at no delivery. And if Jackpot said, hey, haha, we're going to close at 9 p.m., well, that serves them no good. They're going to lose $10 as well. Okay. So, anyway, that is the Nash equilibrium. So, the profit earned by Boulevard in the Nash equilibrium is $30. Okay. And you're going to have to use dominant strategies to kind of figure that out and to show that. Okay. All right. It was kind of nice. This question pointed you towards that direction. Okay. Suppose these two firms merge to form one company with two locations and still face the same actions and payoffs. What strategy would the new company choose to maximize combined profit? Oh, that's a very cool question. So now there's no competition, and we're just gonna choose where we make the most. So this is right here is what 65, and that's the point of a Nash equilibrium is uh, is that sometimes the outcome that we get is not the best outcome for the overall benefit of everybody or for the kind of the common good. So actually the best is this 9 p.m. and no delivery option. We get $85. Okay. So that's what they would choose if they combined it. So they'd choose no delivery and they would choose 9 p.m. to close. Okay. Terrific. All right. Now assume instead of merging, Jackpot proposes a plan to cooperate with Boulevard. Okay. Jackpot would agree to close at 9 p.m. and Boulevard would agree to no delivery. All right. If either firm breaks the agreement, it must subtract $12 from its profits and then add, and then that is then added to the other firm's profit. Assume the agreement is in effect and enforced. Redraw the matrix, shows the players' actions and payoffs. Assume Boulevard is profit maximizing firm and there's no antitrust concerns. Would Boulevard agree to Jackpot's proposal? Explain using specific values from the redrawn payoff matrix. Okay, so very interesting question, very a little complicated here. Okay, so um, see, this is the best outcome. This is the collusion outcome. Okay. The problem with the collusion at this point is that, yes, there's too much incentive to cheat. Okay. Because, oh, yeah, we'll stay open till 9 p.m., says Jackpot, but they could easily go, boom, let's go and close at 6 p.m. and make an extra $10. Or Boulevard could say, "Oh yeah, we won't cheat. We'll not deliver," and then boom, they could cheat and deliver and cause and get $50. Okay, so even though that this 40, 45, and 40 is the best outcome for both of them, um, if they could just collude, it opens itself up to cheating, and that's why we have this Nash equilibrium up here. Okay, but anyway, so they've proposed a plan to collude and they're gonna affect the rules of the game. So it says that if either firm breaks the agreement, it must subtract $12 from its profit that is then added to the other firm's profit. So they basically have to give somebody $12. Okay, so let's look. All right, so I'm gonna draw my payoff matrix. Okay, 45 and 40 is right here. Okay. So if so let's start with the 9 p.m. is what Jackpot agrees to, and they get $25 usually. But if Boulevard cheats, they'll get an extra $5, or I mean, an extra $12. So that means they would get what, 37? Okay. And then, but if that means Boulevard cheats, and usually they get 50, but um, we'll subtract $12 from this, and we will get $38. Okay. All right. So that's if Boulevard cheats. Okay. I think this corner the Nash equilibrium corner. I think that'll stay the same because that means they both cheated, so they just pay each other $12. I guess 35 and 30. All right. Um, so then in this case up here, this means that Boulevard doesn't cheat. They keep no delivery, but Jackpot does cheat. So so Boulevard is going to get an extra $12. So they get $32. We're going to subtract $12 and from Jackpot, and they'll get 33. Okay. Alrighty. So we made our matrix. Same Boulevard as profit maximizing firm. There's no antitrust concern. So would Boulevard agree to Jackpot's proposal, explain using specific values in the redrawn matrix? And let's see. So, uh, fairly good deal for Boulevard because that's where they will now maximize profit because this is more than because 40 is better than 32 and 38. They're also not too worried about Jackpot cheating. Okay, because if that happens, um, if Jackpot cheats, then, or they're not worried about them cheating because Jackpot won't cheat either. Because if Jackpot goes down to 6 p.m., they lose money too. Okay. So, yeah, I think this is a pretty good deal because 30 is greater than 40 is greater than 32 and 40 is greater than 38. So, there's no real reason for them to deviate from the plan. And then also, 45 is greater than 33 for Jackpot. So, there's really no reason for them to deviate from the plan either. So, it's a pretty good deal. Okay. So, let's go into the scoring guide on this one. All right. One point, dominant strategies close at 6 p.m. We talked about that. 1 point is earned for saying that there is not the profit maxing, saying that this is not a profit maximizing action for Boulevard Garden. Explain that Boulevard earned $30 by choosing delivery instead of $20 and choosing no delivery. What one was that? Yeah, so they're going to choose no delivery. Yeah, they're going to choose delivery instead of no delivery. Okay. 1 point is earned for identifying the profit for is $30. So we're up in that corner. 1 point is earned for saying that they would choose to close at 9 p.m. and offer no delivery. Which question was that? Um, yeah, that's the kind of the collusion agreement. They'd be in kind of the opposite end. Looks like we drew our matrix fine, or did we? No. 1 point is earned for will agree to explain that Boulevard is better off because it's increased the payoff from $30 to $40. Okay, yeah. So that's explaining that the new Nash equilibrium is here rather than here. Did we do some math wrong? Must have done a little math wrong. Oh, 55 minus 12. Oh, that's 43. My bad. That was stupid. Okay, that was my concern. Yeah, so we're good then. And their explanation was even a little easier than mine. This shows that The new at Nash equilibrium, or the one of the new Nash equilibria is this right here. There's no incentive to cheat from this new point right here. So that's pretty easy for Boulevard that they don't want to do this 30 versus this 40, or they'll want to do this 40 versus this 30. Okay. Kind of creates a new equilibrium. All right. Thanks for the attention.